Hey, mathematicians, and today we are going to be talking about triangles. We're going to be talking about how to identify triangles because there's different ones all around us. There's triangles on the pyramids and shapes outside, and even in our classroom if you look around. Let's get into our lesson for today. Remember, your I will statements are your goals for this lesson. They are what we are trying to work on and learn more about throughout our time together today. As we continue on in our lesson, make sure you have your mind focused on these three things and showing them to your teacher. I will read the I will statement first, and then we will read it again a second time together. Make sure you're reading it nice and loudly so I can hear you, but no shouting necessary. Let's go through our I will statements for today. Listen first. I will identify angles and their names. Read it with me. I will identify angles and their names. Number 2. I will classify triangles by angles. Read it with me. I will classify triangles by angles. And our last one, listen first. I will name attributes of triangles. Say it with me. I will name attributes of triangles. Good job, mathematicians. Today, you're going to be playing a Mirror Me game or a symmetry game. You're going to need to partner up with somebody who's about the same height as you or someone who's close to it. Your partner is going to decide, in your groups, you'll decide who is partner A and who is partner B. Your teacher will call out who is to start, partner A or B. That partner will start by striking a pose. Their partner's job is to model that pose exactly the same, or like symmetry, like looking in a mirror. Lines of symmetry represent being able to fold an image over, and it's the same thing. So if your partner sticks up one arm, you're going to do the same. Remember, when we fold something on a line of symmetry, both sides came out the same. For our next activity, you guys are just going to need to be seated and listen carefully. I'm going to draw a picture on the board, and I will draw a line of symmetry on that picture. For example, if I drew a square, try and draw it as straight as I can. If I drew a square and I said its line of symmetry was, one of its lines of symmetry was down the middle like that, if you agree that this line of symmetry, this is a line of symmetry, you are going to stand up. If you don't think the shape or the line is a line of symmetry, then you will stay sitting down. So the game is called stand up or sit down. If you agree, you stand up. If you disagree, you stay seated. So if you agree, if this is the line of symmetry, stand up now. If you don't think this is a line of symmetry, then don't stand up. You should be standing. This is a line of symmetry. It goes right down the middle. Everybody take your seat. We're going to reset. After each shape, you'll reset. I'll erase the picture and I'll draw a new one. I'll kind of hide it so you can't see it. And I'll draw the line of symmetry. Ready? Stand up if you agree that's the line of symmetry. Sit down if you don't. Good. We should be standing up. The arrow is split right down the middle, making it its line of symmetry. Let's go to our next one. Sit back down. We'll reset. Do you think that's a line of symmetry? Stand up if you agree. Sit down if you don't. Good. We should be seated. That's not a line of symmetry. If I folded that over, I'd have a lot of extra space on the other side. Remember, your line of symmetry splits something perfectly in half. All right, let's see if I get my next one. And remember, I'm not an artist either, so my pictures might not be perfect. Let's do this one. Is this a line of symmetry? Yeah, if we were to fold our shapes over, you should be standing up. This would be a line of symmetry. Let's do another one. Let's see. I'm going to go like this. Is this a line of symmetry? No, it's not. Remember, we practiced with the rectangles in one of our other lessons. If we were to fold it diagonally, the rectangle wouldn't fold right. It doesn't have all equal sides. Okay, let's do one more. We'll do a funky shape here. We'll make it look nice. All right, if we folded our shape right along that line, would that be a line of symmetry? Stand up if you agree, stay seated if you disagree. You should all be seated. This is not a line of symmetry. Good job, mathematicians. Let's get into our lesson for today where we're going to be talking about a specific shape, a triangle. Some triangles do have a line of symmetry. And some triangles do not have a line of symmetry. So we're going to be looking at those different kinds of triangles today and how you would classify different triangles when they look differently and what you would call them. There's different ways to classify triangles. Looking at the triangles on the whiteboard I have here, there's some obvious things that we can point out. The first thing is all the triangles have 3 sides, so that must mean they have at least 3 angles in them. And that's true for all triangles. Looking at the triangles, I can see that some of them have shorter sides and some of them have longer sides as well. It just depends on what triangle you're looking at. Some of the lengths of the sides are going to be different. The length of the sides can be different, but I also see that some of the angles are different. I see some right angles, some acute angles, and even some obtuse angles in our triangles. And like we talked about before, I see some of our triangles have lines of symmetry. Like triangle A, if I were to fold this one right in half, it folds in half perfectly. And if I open it up, each side, it actually gives me 2 tiny right triangles that are equal to one another. But if I took triangle C over here and tried to fold that one in half, well, that's not a line of symmetry. Not only does our paper not line up, but when I unfold it, the 2 sides of the line are not equal to one another. To talk about the names of our triangles, let's pull out triangles that look like each other. So we just talked about how some of them have some differences. Let's pull out the ones that look alike. We'll go to C, F, A, and B later. Right now, we're going to look at triangles E and triangle D. If I look at both of these triangles, I notice that they each have a right angle. Remember, when we are representing a right angle in a shape or as an angle, we draw a small box where that right angle would be to show us that that's 90 degrees. If you ever see that box in a triangle or representing an angle, it's telling you it's a 90-degree angle. You won't even have to measure it with your protractor. That's a definite 90 degree. Since both of these triangles have at least one right angle in them, these triangles are called right triangles. Everybody say that with me. Right triangles. To be a right triangle, you have to have a right angle. So an easy way to spot these triangles is look for those squares in the corner. Now, just because there's not a square doesn't mean it's not a right angle. Sometimes you may have to measure or look further into the details to figure out the measurements. But if you see that tiny square in the corner, you can already tell that that one's going to be a right triangle. Let's look at 2 of our other triangles. We're going to look at triangles C and triangle F. These 2 triangles come with obtuse angles. I look down here and this one has C has an obtuse angle and F has an obtuse angle. Now, they have 2 acute angles as well, but I see that they both have at least one obtuse angle. If you see in a triangle that it has at least one obtuse angle, that means that it's an obtuse triangle. Remember, an obtuse angle is an angle that's greater than 90 degrees. If I look at these two triangles, although they have two acute sides, they have at least one obtuse angle, making it an obtuse triangle. So far we've seen obtuse triangles and we've seen right triangles. Those deal a lot with the angles we've talked about before. Does anyone want to take a guess at what vocabulary word might be in our last triangles as I set it up? Our last triangles are triangle A and triangle B. These two triangles each have acute angles as all of their sides. Because they have an acute angle on each side, these are called acute triangles. All sides of an acute triangle will have acute angles. So each of the angles will be less than 90 degrees. The difference between the acute and the obtuse triangle is the obtuse triangle had two acute angles, but it had one obtuse. The acute triangle has all acute angles. Now, you guys are going to practice a little bit more with triangles and identifying acute, obtuse, and right triangles. Good luck. And if you get stuck, remember, check the angles to help you identify which triangle you're working with. Talk to you next time, mathematicians.